In this practice, initially both capacitors are charged to 20 volt. How long does it take to reduce the potential across each capacitor to 10 volt after the switch S is closed? At first, we find the equivalent capacitance. Two capacitors are connected in parallel. Equivalent capacitance is given by sum of the two capacitors. So two parallel connections, C sub 1 and C sub 2. Equivalent capacitors, C sub equivalent, is given by sum of C sub 1 and C sub 2. In this case, 40 microfarad and 10 microfarad. So it becomes 50 microfarad. This is the equivalent capacitance. Then we'd like to find the stored charge in the capacitor. This is C equivalent and the voltage V sub 0. So charge, positive charge is stored, negative charge is stored. Stored charge of the Q sub 0 can be calculated C eq times V sub 0. The V sub 0 is a 20 volt. Then this is equivalent, is a 50 microfarad. So it becomes 1000 microcoulomb. So this is 10 to minus 3 coulomb. This is the amount of charge stored in capacitors. Then we consider the RC circuit. The charge on the capacitors can be calculated in the RC circuit. Q is a Q sub 0 times exponential minus T over RC. Energy is reduced by the resistor, so charge is decreasing with times. Charge on the capacitors also calculated. Q equal equivalent capacitance times voltage. The practice said reduce the potential across each capacitor to the 10 volt. So this is lower case of the V. So this is lower case of the V is a 10 volt. Then using these two equations, you can find the C equivalent. V equal Q sub 0 exponential minus T over RC. Q sub 0 is C sub equivalent V sub 0. C sub equivalent gonna be cancelled out. So V over V sub 0 equal exponential minus T over RC. So from these equations, you can find the T is gonna be RC log, this is the equivalent capacitance, and the V sub 0 over B. Then this is gonna be 20 volt. This is 10 volt. This is 10 ohm. This is 50 microfarad. So it becomes 5 times 10 to 2 times 10 to minus 6. This is the micro. Times log 2 second. Then it becomes 3.465 times 10 to minus 4 second. So express the answer with the three significant figures, 3.47 times 10 to minus 4 second. This is the answer to this practice.